This is a video on double integrals in polar coordinates. The question states, evaluate the double integral over the region R of the square root of x squared plus y squared dy dx, where R is the region in the first quadrant below the curve y equals the square root of 4 minus x squared, and above the curve y equals x. So let's first sketch a picture. Notice that y equals the square root of 4 minus x squared is a semicircle, and y equals x is just a line. So here's my picture. I have the line y equals x, and then I have the piece of the circle, y equals the square root of 4 minus x squared, and I'm looking at the region in the first quadrant. So I could integrate this, putting my little man vertically, but instead it's a lot easier to use polar coordinates. And that's because y equals the square root of 4 minus x squared is a semicircle, and circles work really well in polar coordinates. Notice that the square root of x squared plus y squared is also nicer in polar coordinates. So I can convert y equals the square root of 4 minus x squared to r equals 2, because r equals 2 is a circle of radius 2. And y equals x, that's this line that becomes theta equals pi over 4. And also, it's in the first quadrant, so I'm going to go to theta equals pi over 2, because that's the y-axis. For the square root of x squared plus y squared, in polar coordinates, that's just r. And then finally, dy dx converts to r dr d theta. So I can put that together and say that this double integral is the double integral in polar coordinates from theta equals pi over 4 to theta equals pi over 2, r equals 0, because that's where the feet are, to r equals 2, because that's where the head is. And then the square root of x squared plus y squared was r, and dy dx is r dr d theta. So now I can integrate. R times r is r squared, and the integral of r squared is r cubed over 3. I can pull the 1/3 outside and have the integral from pi over 4 to pi over 2 of r cubed from 0 to 2 d theta. Well, 2 cubed is 8, and 0 cubed, of course, is 0. 8 minus 0 is 8. And I can pull that 8 outside and get 8/3 times the integral from pi over 4 to pi over 2 of just d theta. And the integral of d theta is theta, and I'm going from pi over 2 to pi over 4. Pi over 2 minus pi over 4 is pi over 4. And pi over 4 times 8/3, the 8 and the 4 cancel as a 2/3. And I get 2 pi over 3. So I can conclude that this double integral is equal to 2 pi over 3. And I'm done with the problem.